അപ്പോൾ ലൈവ് അല്ലേ? ലൈവ് ആണല്ലേ? അപ്പോൾ വെൽക്കം ബാക്ക്. നമ്മുടെ ചാപ്റ്റർ കഴിഞ്ഞു. മാഗ്നറ്റിക് എഫക്ട്സ് ഓഫ് ഇലക്ട്രിക് കറന്റ് ചാപ്റ്റർ കഴിഞ്ഞു. നമ്മൾ ജസ്റ്റ് അതിലത്തെ ഒന്ന് ജസ്റ്റ് ഫോർമുലാസ് ഒരു വട്ടം കൂടി എഴുതുന്നു. അതിനുശേഷം നേരെ പ്രോബ്ലംസ് ആണ്. പ്രോബ്ലംസോടുകൂടി ചാപ്റ്റർ കഴിയാണ് കേട്ടോ. എന്തൊക്കെയാ മാഗ്നറ്റിക് ഇഫക്ട്സ് ഓഫ് ഇലക്ട്രിക് കറന്റ് ഫോർമുല? ലോറൻസ് മാഗ്നറ്റിക് ഫോഴ്സിന്റെ ഫോർമുല എന്താ? Q ഇൻറ്റു വി വെക്ടർ ക്രോസ് ബി വെക്ടർ. ലോറൻസ് ഇലക്ട്രിക് ഫോഴ്സിന്റെ ഫോർമുല എന്താ? QE. പിന്നെ ചാർജ് പാർട്ടിക്കൽ എൻട്രിങ് പെർപെൻഡിക്കുലർ ടു എ മാഗ്നറ്റിക് ഫീൽഡ് വിൽ ഫോളോ വാട്ട് പാത്ത്? സർക്കുലർ പാത്ത്. അതിന് റേഡിയസിന്റെ ഇക്വേഷൻ എന്താ? mv/bq. വെലോസിറ്റി ഇക്വേഷൻ എന്താ? bq/r/m. മറക്കല്ലേ, ഓർമ്മിക്കാൻ വേണ്ടി പറയാണ്. അതിൽ bq/m എന്താ? കോൺസ്റ്റന്റ് ആണ്. അതിന്റെ അർത്ഥം എന്താ? വെലോസിറ്റി ഡയറക്ട്ലി പ്രൊപ്പോർഷൻ ടു എന്താ? റേഡിയസ് ആണ്. ഫ്രീക്വൻസിയുടെ ഇക്വേഷൻ എന്താ? bq/2πm. ടൈം പീരീഡിന്റെ ഇക്വേഷൻ എന്താ? 2πm/bq. എന്നിട്ട് ബോത്ത് ഫ്രീക്വൻസി ആൻഡ് ടൈം പീരീഡ് ആർ ഇൻഡിപെൻഡന്റ് ഓഫ് ആരാ? വെലോസിറ്റി ആൻഡ് റേഡിയസ്. ഇൻഡിപെൻഡന്റ് ഓഫ് വെലോസിറ്റി ആൻഡ് റേഡിയസ്. ജസ്റ്റ് ഞാൻ ഫൈനൽ ടച്ചപ്പ് പറയാണ് കേട്ടോ. ചാപ്റ്ററിന്റെ ഫൈനൽ ഇക്വേഷൻസ് പറഞ്ഞ് അവസാനിപ്പിക്കുകയാണ്. ഇൻഡിപെൻഡന്റ് ഓഫ് വെലോസിറ്റി ആൻഡ് റേഡിയസ്. പിന്നെ ഫോഴ്സ് എക്സ്പീരിയൻസ്ഡ് ബൈ കറന്റ് ക്യാരിയിങ് കണ്ടക്ടർ പ്ലേസ്ഡ് ഇൻ എ യൂണിഫോം മാഗ്നറ്റിക് ഫീൽഡ് എന്താ? ബിൽ സൈൻ തീറ്റ. ഇനി ചാർജർ പാർട്ടിക്കിൾ ഫോഴ്സ് എക്സ്പീരിയൻസ് ചെയ്യാതെ മാഗ്നറ്റിക് ഫീൽഡിൽ കൂടെ പോകാൻ പറ്റുമോ? ആൻസർ എന്താ? പറ്റും. പ്രൊവൈഡഡ് ചാർജ് പാർട്ടിക്കിൾ മൂവ് either in the direction of magnetic field or opposite to the direction of magnetic field, force will be 0. Now force experienced by current carrying conductor placed in a uniform magnetic field is what? Bill sin theta. What is Bill sin theta? Force experienced by current carrying conductor placed in a uniform magnetic field. Then we have 5 points. Magnetic force always perpendicular to velocity. Magnetic force perpendicular to velocity. Magnetic force perpendicular to displacement. Work done 0. Work done by a magnetic force on a charged particle is what? 0. Why? Because perpendicular work done will be 0. Work done 0 means what? Changing kinetic energy equal to 0. That is kinetic energy equal to what? Constant. So please do remember these 5 points. Magnetic force perpendicular to velocity, magnetic force perpendicular to displacement, work done 0, changing energy 0, kinetic energy equal to constant. So please do remember these 5 points. Now next concept, Ampere's circuit law. Ampere's circuit law. What is our formula? Integral over L B vector dot dl vector is equal to what? Mu 0 times I. Mu 0 times I. Then magnetic field due to long straight current carrying conductor. Long straight current carrying conductor. Magnetic field due to long straight current carrying conductor at a point P, at a distance R from conductor. What is the formula? At a distance R from conductor. What is the formula? B is equal to mu 0 I by 2 pi R. So B directly proportional to 1 by R. As R value increases, B value decreases. Then what is the next? Magnetic field due to solenoid. What is the magnetic field due to solenoid? V equal to mu 0 Ni. where small letter n is what? Number of turns per unit length, it is equal to capital letter N by L. So B equal to mu 0 capital letter N by L into I. So magnetic field due to solenoid. Yeah, good evening. All of you, good evening. Manoj Kumar, Alachand, Aliya. B equal to mu 0 N by L into I. Now, what is the value of mu 0? 4 pi into 10 raised to minus 7 Tesla meter per ampere. Now, what is the value of epsilon 0? 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. Now, what is the relation between them? C is equal to 1 by root mu 0 epsilon 0. V is equal to 1 by root mu 0 mu r into epsilon 0 epsilon r. So, V is equal to C by root mu 0, sorry, mu r epsilon r. All these relations are very, very important for entrance. Very, very important relations. Then magnetic field along the axis of circular current carrying loop. Circular current carrying loop. What is the formula for magnetic field along the axis of a circular current carrying loop? B axis is equal to mu 0 Ni a square divided by 2 into a square plus r square all raised to 3 by 2. If there is only one turn, mu 0 I a square divided by 2 into a square plus r square all raised to 3 by 2. Now, magnetic field at the center of the loop. What is the formula? Mu 0 Ni by 2a. Magnetic field at the center, if there is only one turn, what is the formula? Mu 0 I by 2a. Now, magnetic field at a distance r equal to, distance from the center r equal to radius. Then what is the formula? Mu 0 Ni by 2 raised to 5 by 2 into a, where a is what? Radius of circular loop. Circular current carrying loop. Current carrying loop. Please note it fast. Please note it fast. Any doubt? Will it doubt unda? Equations doubt unda? നമ്മൾ പലവട്ടം പറഞ്ഞിട്ടുള്ളതാണ്. ഇന്ന് ലാസ്റ്റ് ക്ലാസ് ആണ് ഈ ചാപ്റ്ററിന്റെ. മുഹമ്മദ് അലി ഹായ്. ഹായ് ഹായ്, ഗുഡ് ഈവനിങ്. നോട്ട് ചെയ്യണ്ട? നിങ്ങൾ പ്ലസ് ടു നിങ്ങൾ പ്ലസ് ടു അല്ലേ? ഓക്കെ അല്ലേ? ഞാൻ നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? ഡൗട്ട് ഉണ്ടോ? നമ്മൾ ഈ ചാപ്റ്ററിനോട് വിട പറയാൻ പോവാണ്. അതിനു മുമ്പ് എല്ലാ ഇക്വേഷൻസും ഒന്ന് പരിചയപ്പെടാണ്. എല്ലാം നമ്മൾ ഡിറൈവ് ചെയ്താ. അയ്യോ, ബയോട്ട്-സവാർട്ട്സിലോ എഴുതിയില്ല. എഴുതി കഴിഞ്ഞ എല്ലാവരും? That is already said. Yeah. Biot-Savart's law. Biot-Savart's law dB is equal to mu 0 by 4 pi I dl sine theta by r square. Its vector form dB vector is equal to mu 0 by 4 pi I into dl vector cross r vector divided by r cube. Vector form of Biot-Savart's law. Then define force between two current carrying conductors mu 0 I1 I2 L by 2 pi r. Force per unit length means L will go mu 0 I1 I2 divided by 2 pi r, and if I1 equal to I2 equal to 1 ampere, r equal to 1 meter, then force between two current carrying conductors per unit length will be what? 2 into 10 raised to minus 7 Newton per meter. With that data, we can define 1 ampere. 1 ampere is that value of steady current which on flowing through two infinitely long straight current carrying conductors carrying current 1 ampere each, placed in air or vacuum, will attract or repel with a force of 2 into 10 raised to minus 7 Newton per meter. We know that I1 equal to I2 is equal to 1 ampere, r equal to 1 meter, then force per unit length will be what? 2 into 10 raised to minus 7 Newton per meter. Now unit of magnetic field magnetic induction, magnetic flux density, everything is what? Represented by units. One is Tesla, other one is what? Weber per meter square, another unit volt second per meter square. Magnetic flux phi is equal to B vector dot A vector. Phi is equal to BA cos theta. If there are n turns, phi equal to NBA cos theta, where n number of turns. It's very important to know that theta angle between normal to area and B vector. Normal to area and B vector. Then torque experienced by a current carrying loop placed in a uniform magnetic field, torque equal to a bin sin theta. That also we know. Now next, moving coil galvanometer. Deflecting torque is what? A bin. Restoring torque is what? C theta. So theta equal to what? A bin by C. In that equation, A, B, and C are constants. So theta directly proportional to I, angle turn directly proportional to I. Then current sensitivity theta by I equal to ABN by C. In order to increase current sensitivity, what you have to do? Increase area, increase magnetic field, increase number of turns, decrease torsion constant. C is what? Couple per unit test or torsion constant. What is voltage sensitivity? Theta by V, ABN by CR. But in order to increase voltage sensitivity, what you have to do? Increase A, increase B, decrease C. Increasing number of turns doesn't result in increased voltage sensitivity. Because when number of turns increases, length also increases, resistance also increases. So N by R is a constant. Don't forget that. Now, unit of current sensitivity, radians per ampere. Radians per ampere. Now, unit of voltage sensitivity is what? Radians per volt. Don't forget this. Now, how to convert a galvanometer to ammeter? A galvanometer can be converted to an ammeter by connecting a small resistance called shunt resistance in parallel to the galvanometer. So, what is that small resistance value? R equal to IgG by I minus Ig. What is that formula? IgG by I minus Ig. Now, in order to convert a galvanometer to voltmeter, what you have to do? You have to connect a high resistance in series to the galvanometer. What is the value of that high resistance? V by Ig minus G. This is the value of high resistance that should be connected in series to galvanometer in order to convert that galvanometer to voltmeter. Any doubt? Anas, any doubt? Sweda, any doubt? Kabila, any doubt? These are the formulas that are required for doing problems. Please note it down. Anas, I hope it is clear. Please note it down. Plus 2 plus. Equations ഒക്കെ പഠിക്കട്ടോ, equations ഒക്കെ പഠിക്കുക, എന്നാലേ നമുക്ക് നമ്മുടെ കാര്യങ്ങൾ നടത്താൻ പറ്റുള്ളൂ. Anas, don't worry, I will be helping you. No, don't worry. Please note it down fast. I hope all of you done. All of you noted this. Any doubt? Any doubt? Done, right? All of you done? Okay. So we are starting again problems. Let's see. A galvanometer a galvanometer with a coil resistance of 12 ohm shows full scale deflection for a current of 2.5 milliampere. How will you convert this to an ammeter, of 0 to 7.5 ampere? That ammeter should read a current of 0 to 7.5. Don't understand that as 0 minus 7.5. That particular galvanometer has to be converted to an ammeter to measure current in the range of 0 to 7.5 ampere. That is the first case. And the second case, voltmeter. Same galvanometer has to be converted to a voltmeter 0 to 10 volt. So this is the task that is given to us. Now, how will you convert that to an ammeter? In order to convert a galvanometer to ammeter, we should connect a small resistance called shunt resistance in parallel to the galvanometer. And what should be that resistance value? R equal to IgG by I minus Ig. Now, what is the galvanometer current? Galvanometer resistance is what? 12 ohm. So, G is equal to what? 12 ohm. Full scale deflection for a current of 2.5 milliampere. Galvanometer shows full scale deflection for a current of 2.5 milliampere means what? It is the galvanometer current. So that Ig is equal to what? 2.5 milliampere. Now you have to convert that to an ammeter. That ammeter current range is 0 to 7.5. That means total current is what? 0 to 7.5. So we can take what? 7.5. So what is the formula? R equal to, what is Ig? 2.5 into 10 raised to minus 3. 2.5 Ig, that should be converted to milliampere, should be converted to ampere, into what is the galvanometer resistance? 12, divided by total current is what? 7.5 minus galvanometer current is what? 2.5 into 10 raised to minus 3. So that is the answer. If you solve that, you will get the answer 7.5 into 2.5 minus. If you solve that, you will get the answer as 4 into 10 raised to minus 3 ohm. If you solve this, you will get the answer 4 into 10 raised to minus 3 ohm. So in order to convert this galvanometer to ammeter, I should connect a resistance of 4 into 10 raised to minus 3 ohm in parallel to the galvanometer. Four into 10 raised to minus 3. And as entrance issues, we will be handling that. Don't worry. Alan Chand, mone 4 into 10 raised to minus 3. അപ്പോൾ 0.004 ആണ് കിട്ടുന്നത് കേട്ടോ. നീ ഒന്ന് ചെക്ക് ചെയ്ത ആൻസർ. നീ പറഞ്ഞ ആൻസറിൽ ഒരു ഡിജിറ്റ് കുറവാ. ചെയ്ത് കാണിക്കണോ? വേണ്ടല്ലോ, ഡയറക്റ്റ് അല്ലേ, കുഴപ്പമില്ലല്ലോ. ചെയ്ത് നോക്കി ആൻസർ കിട്ടും. ഇനി അതിന് നമ്മൾ എന്ത് ചെയ്യണം? വോൾട്ട് മീറ്റർ ആയിട്ട് കൺവേർട്ട് ചെയ്യണം. വോൾട്ട് മീറ്റർ ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്ന റെസിസ്റ്റൻസിന്റെ വാല്യൂ കണ്ടുപിടിക്കുക. ആർ ഈക്വൽ ടു വി ബൈ ഐ ജി മൈനസ് ജി. അപ്പോൾ വി എത്രയാ? എത്രേന്റെ വോൾട്ട്? ഹൗ മച്ച് വോൾട്ട് മീറ്റർ ഐ ഷുഡ് യൂസ്? 0 to 10 volt means what? V equal to 10 volt. And Ig is equal to what? 2 into 2.5 2.5 into 10 raised to minus 3 ampere, and the galvanometer resistance is what? 12 ohm, I think. Yeah. So R equal to 10 divided by 2.5 into 10 raised to minus 3 minus 12. So 10 into 10 raised to minus 3, no, it becomes plus 3 divided by 2.5 minus 12. That is 10 into 10 raised to 3 is what? Here it becomes 4, that is 4000 minus 12. So the resistance that has to be connected in series with the galvanometer in order to convert that to a voltmeter is 3988 ohm. And this much resistance should be connected. Yeah, Alinson, check your answer. 3988 is answer. 3982. So from the figure, from the calculation, we are again understanding that we have to convert a very small resistance in parallel to galvanometer to make it to an ammeter, and we have to connect a very high resistance in series to galvanometer to make it a voltmeter. Any doubt? Done? All of you done? Done, right? Next question. An ammeter of resistance 0.8 ohm can measure currents up to 1 ampere. 1 ampere. Now what must be the shunt resistance to enable the ammeter to measure current up to 5 ampere. What is the combined resistance of ammeter and shunt. Ammeter and shunt. What is the combined resistance of ammeter and shunt? Now, what is the now in this question, ammeter resistance is given. So, resistance of ammeter is given. So, you can consider this ammeter as a galvanometer. It's an NCERT problem. Not only NCERT problem, it was a question in CBSE 2013 and 2020. Now, you can simply consider this ammeter. Then you can say, what is the ammeter resistance? That is what? Galvanometer resistance. This is what? 0.8 ohm. See, ammeter is you also use to measure current. So, in the previous case, it was clearly given galvanometer. Now, in this case, we can consider this ammeter as what? Galvanometer. So, ammeter resistance 0.8 ohm means what? Galvanometer resistance is 0.8 ohm. It can measure current up to 1 ampere means what? The current through galvanometer is what? 1 ampere. Now, what must be the shunt resistance? That shunt means, remember, shunt means parallel. So, what should be the parallel resistance to enable the ammeter to measure current up to 5 ampere? That is, the current that has to be measured is what? 5 ampere. And what is that parallel resistance value? IgG by I minus Ig. So, what is Ig here? Galvanometer current 1 into galvanometer resistance is what? 0.8 divided by total current is what? 5 minus galvanometer current is what? 1. So, R is equal to what? 0.8 divided by 4. So, what is the answer? That is 8 divided by 40. That is 2 by 10. Not 2 by 10. Into 1 by 5. Yeah, 2 by 10. You can directly go for 1 by 5. 1 by 5, that is 0.2. 0.2 ohm is the resistance that has to be connected in parallel to the ammeter in order to make it measure a current of 5 ampere. Now, what is a combined resistance? Now, these two are in parallel. So, original resistance is what? 0.8 ohm and there is another resistance 0.2 ohm in parallel. So, what is the total resistance? What is the formula? Since it is in parallel combination, formula R1 R2 divided by R1 plus R2. So, 0.8 into 0.2 divided by 0.8 plus 0.2. So, 0.16 divided by 1. So, 0.16 ohm. 0.16 ohm is the answer. Yeah, 0.2 ohm correct. What is the total resistance? 0.2. Shweta, clear, right? Alan Chand, Shweta, clear, right? Done? Got it. Next, I will do a moving coil galvanometer problem. a rectangular coil of area 5 into 10 raised to minus 4 meters square and 60 turns. The coil is in a magnetic field of in a horizontal magnetic field of 90 G. G stands for Gauss. Yeah, I forgot to while writing the equations, I forgot to write Gauss. For magnetic field, there is another unit called Gauss, and we know that 1 Gauss equal to 10 raised to minus 4 Tesla. 90 Gauss. What is the torsional constant? What is the torsional constant? Torsional constant if a current of 0.2 milliampere produces an angular deflection of 18 degree. Produces an angular deflection of what? 18 degree. So this is the question. We are supposed to do. Now, in the moving coil galvanometer, we know that deflecting torque is equal to what? A bin. Restoring torque directly proportional to angle turned. Restoring torque is equal to what? C theta. In our derivation, I had used what? C. And this C is what? Couple per unit twist. And I told you it is also called what? Galvanometer constant. Sorry, not galvanometer constant, torsion constant. Now at equilibrium, what happens? A bin equal to what? C theta. So C is equal to what? A bin equal to C theta. So C equal to what? A bin by theta. Remember, C is equal to what? A bin by theta. Please remember that. C equal to a bin by theta. Now, what is torsional constant? Actually, this part is not required, and for your understanding only I have written this. In our derivation, we gave the variable C for torsion constant, which is also called couple per unit twist. Theta is angle of twist. So we have to use the formula C equal to A bin by theta. Now what is A? What are the data? A equal to what? What is the area? 5 into 10 raised to minus 4 meters square. Okay. And then what? What is the magnetic field? 90 Gauss. That is 90 into 10 raised to minus 4, because 1 Gauss is what? 1 Gauss is 10 raised to minus 4 Tesla, that we know. If a current is what? 0.2. And how many turns are there? 60 turns. So capital letter N equal to 60. Then any other data? And theta is what? 18 degree. Theta equal to 18 degree. So C is equal to 5 into 10 raised to minus 4 into 90 into 10 raised to minus 4 into I is what? 0.2 into 60 divided by 18. So this is the expected answer. Means this is the equation substitution. If you solve that, you will get 3 into 10 raised to minus 9 Newton meter per degree. Newton meter per degree. Why Newton meter per degree? Because the equation for C is what? Abin by theta. What is Abin? You remember that torque is what? Abin sin theta. That torque is Abin. So torque unit is what? Newton meter. By angle is what? 90. By angle is what? Angle is given in degree. So I am not converting. So I am writing Newton meter per degree. Any doubts? Any doubt? അത് മനസ്സിലായോ? See, some students might be thinking, sir, 18 degree is not SI unit. For those I am telling you, 360 degree is equal to 2 pi radians. So 1 degree is equal to what? 2 pi by 360. That is 1 degree 1.745 into 10 raised to minus 2. So in order to convert that to radians, you can say 1 degree is 1.745 into 10 raised to minus 2. So in order to convert 18 degree, you have to multiply 18 into 1.745 into 10 raised to minus 2 in the denominator. Then you will get that much Newton meter per radian, which is the SI unit. But I am not going for that much lengthy calculation that you can do, but I have explained how to do that in radians also. And please remember this equation, 360 degree is equal to 2 pi radians and 1 degree corresponds to 1.745 into 10 raised to minus 2 radian. The 0.2 milliampere, yeah, sorry, I forgot to convert 0.2 into 10 raised to minus 3. Final answer no change, because final answer I have not done the calculation. I simply copied the final answer. So I forgot to write 0.2 into 10 raised to minus 3. Sweta, thank you for reminding me. A milliampere has to be converted to ampere. Final answer remains the same. I simply forgot to convert that. Means forgot to add that step. Thank you, Sweta. Any doubt? Any doubt? All of you completed? Noted, all of you noted? So that part is done. Done? Yeah. So next question. See, by the end of today's class, we will be finishing this chapter. The maximum, next question, maximum torque acting on a coil of effective area 0.04 meter square. 0.04 meter square is 4 into 10 raised to minus 8 Newton meter when the current in it is 100 microampere. When the current in it is 100 microampere. Find the magnetic induction. Find the magnetic induction. Find the magnetic induction in which it is kept. In which it is kept. Find the magnetic induction in which it is kept. That's അടുത്ത ടാസ്ക് കേട്ടോ, അടുത്ത പ്രോബ്ലം. മക്കളൊന്നും ആലോചിച്ചേ, 5 മിനിറ്റ് മാഷിരിക്കട്ടെ, തന്നെ ചെയ്യാൻ നോക്കും. മ്യൂട്ടഡ്. Maximum torque ആണ് ചോദിച്ചേക്കണം. Maximum torque ആയ കാരണം we know that it is Abin since it is tau max. Okay. Now effective area is what? 0.04 meter square. Since it is in meter square, no need of conversion. Torque is given. Tau max is what? 4 into 10 raised to minus 8 Newton meter. Units are fine. And the current is I is what? 100 microampere. That means 100 into 10 raised to minus 6. Okay. Find the magnetic induction in which is kept. We know that magnetic induction, magnetic field both are same, or magnetic flux density. So we have to find out what B. So tau max is equal to what? Abin. So B is equal to what? Tau max by AIN. So B is equal to tau max is what? 4 into 10 raised to minus 8 divided by A is 0.04 and the current is what? 100 into 10 raised to minus 6 into number of turns is what? There is number of turns, it's not given. On a coil, so one coil is only, there is only one coil. So B is equal to N value is 1. So if you solve that, your answer will be 10 raised to minus 2. Since it is magnetic field, unit will be Weber per meter square or Tesla or volt second per meter square. Okay. Any doubt? സന്തോഷേടാ, ഓർമ്മയില്ലടാ, നിന്നെ മറക്കാൻ പറ്റുമോ? ഞാൻ ക്ലാസ് എടുക്കല്ലേ സന്തോഷേ, നമുക്ക് പിന്നെ നമുക്ക് സംസാരിക്കാം. സന്തോഷം എനിക്ക് നല്ല ഓർമ്മയുണ്ട്, നിന്നെ മറക്കൂടാ ഞാൻ. സന്തോഷം എന്നെ ഒന്ന് വിളിക്ക്. നോട്ട് ചെയ്യടാ, ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കേ. അല്ല, അവരെൻ്റെ എൻ്റെ സ്റ്റുഡൻസാണ്. കഴിഞ്ഞ കൊല്ലം പഠിപ്പിച്ചിരുന്ന കുട്ടികളാണ്. അവർ മാഷിനെ കണ്ട് സന്തോഷം പ്രകടിപ്പിച്ചതാണ്. ക്ലാസ് കണ്ട് വിളിക്കാൻ പറഞ്ഞു. കഴിഞ്ഞ നോട്ട് ചെയ്താ? കഴിഞ്ഞില്ലേ? ഇനി അടുത്ത ക്വസ്റ്റ്യൻ പ്രോബ്ലം കേട്ടോ. വീണ്ടും പ്രോബ്ലം. കാൽക്കുലേറ്റ് ദ ടോർക്ക് on a 100 turn rectangular coil of length 40 centimeter and breadth 20 centimeter, carrying a current of 10 ampere. Carrying a current of 10 ampere. When placed making an angle of 60 degree with a magnetic field of 3 Tesla. ചിന്തിക്കുക, കാൽക്കുലേറ്റഡ് ടോർക്കാണ്. അപ്പോൾ ടോർക്ക് ഈക്വൽ ടു ക്വസ്റ്റ്യൻ മാർക്ക് ഇട്ടു ഓൺ എ 100 ടേൺ. അപ്പോൾ ടോട്ടൽ നമ്പർ ഓഫ് ടേൺസ് 100 ആണ്, വിരോധമില്ല, നോട്ട് ബാഡ്. ലെങ്ത് 40 centimeter ആൻഡ് ബ്രെഡ്ത്ത് 20 centimeter. ഓക്കെ ലെങ്ത് 40 centimeter, that is 40 into 10 raised to minus 2. Breadth 20 centimeter, that is 20 into 10 raised to minus 2. Okay, meter. So area will be length into breadth, that is 40 into 20 into 10 raised to minus 2 into minus 2, it becomes minus 4 meter. That is 800 into 10 raised to minus 4 meter. That is 8 into 10 raised to minus 2 meter. That is area. Okay. When placed, make an angle of 60 degree. Now this is the problem. So what is theta? So some students will directly jumping into the answer and saying theta is 60 degree, which is wrong. It's a very important problem. What is, by definition, what is theta? Theta is the angle between normal to area and b vector. Now, it is at 60 degree means what? It is kept at an angle of what? 60 degree. Okay, it is kept at an angle of 60 degree. Then theta is not 60 degree. Theta should be 90 minus 60, that is equal to 30 degree, which is very important. It's a common mistake that students make. theta should be what? Instead of 60, it should be what? 90. Why? Because theta is the angle between normal to area and B vector. So here this coil is kept at an angle of 60 degree with the magnetic field. So what is the angle between normal to magnetic field and the coil? That will be what? 90 minus 60, that is equal to 30, which is a very, very important point. Is that point clear, Sweda, Anas? Is that point clear? Why theta I have taken 60 degree? Because theta is the angle between normal to area and the magnetic field. It is at an angle of 60 degree with the magnetic field. So normal to area and magnetic field angle will be what? 90 minus 60, that is equal to 30 degree. Now what I have to find out? Torque, right? So torque is what? Ebb in sin theta. Ebb in sin theta. Rest everything is very simple. So data is what? 8 into 10 raised to minus 2. Okay. What is the magnetic field? Magnetic field is not given. Yeah, 3 Tesla. Magnetic field is 3 Tesla. Since it is in Tesla, no problem. And current is what? Current is 10 ampere. So 10 ampere. So into current 10 into number of turns is what? 100 into sine 30. If you solve that, I am just writing answer directly. Torque will be 120 Newton meter. Torque will be 120 Newton meter. Please note it down. Any doubts? അവിടെയാണോ എവിടെ പിള്ളേര്? Done, right? Next question. A rectangular coil of sides 8 centimeter and 6 centimeter having 2000 turns, and carrying a current of 200 milliampere is placed in a uniform magnetic field of 0.2 Tesla. Directed along positive x-axis. Okay. What is the maximum? What is the maximum torque the coil can experience? The coil can experience. In which orientation? In which orientation? In which orientation does it experience? Does it experience maximum torque? In which orientation does it experience maximum torque? This is the first part. Sides are given 8 centimeter, and so length area will be what? 8 into 10 raised to minus 2 into 6 into 10 raised to minus 2, that is 48 into 10 raised to minus 4 meter. 2000 turns, N is equal to what? 2000. Okay. And carrying a current of I is equal to 200 milliampere, that is 200 into 10 raised to minus 3 ampere. The uniform magnetic field B is equal to what? 0.2 Tesla. Directed along positive x-axis. So tau max is equal to what? Maximum torque. They are asking for maximum torque, means what? We have to find out Abin. Abin is what? 48 into 10 raised to minus 4 into B is what? 0.2 into I is what? 200 into 10 raised to minus 3 into N is what? 2000. Any doubts? Any doubts? Anybody got the answer? Okay, please do that calculation and what is the answer? Say what is the answer. Can anybody do the calculation and write the answer? Anybody got the answer? 10 raised to minus 4, 10 raised to minus 3. 48 into 0.2, 48 into 10 raised to minus 7, 2 into 10 raised to 5 into 0.2. So 48 into 2 into 0.2 is what? 0.4. So 48 into 0.4 into 10 raised to minus 2. 48 into 0.4 is what? 40 into 4, 32, 192. So if you solve that, you will get the answer 0.384 Newton meter. Yeah, 0.384 Newton meter. See, some students might be doing in this way also. They might be thinking tau vector equal to m vector cross b vector. Tau vector is equal to mb sin theta. So maximum torque is what? Theta equal to 90 degree. So sine 90 is equal to 1. So torque is equal to mb. Now we know that magnetic moment m is equal to n turns are there. Magnetic moment m is equal to what? Ia. If there are n turns, magnetic moment n is equal to nia. So torque equal to what? nia into b. That is also a bin. Any doubt? I'm just telling you, some might have been thinking in this way. Some students, both are right only. Any doubts? Say the correct answer. Any doubt? .48 into, I think it should be 0.8. Instead of 0.4, it should be 8. Answer is correct only. 0.2 into 2, 0.4, that is one more 2. So 0.8. 48 into 0.8. Not understand. Yes. Got it? Yeah. And it's 8. Yeah, I have changed, corrected that. 2 into 0.2. 2 into 0.2, and there is one more 2 is there, which I forgot. Any doubts? All of you got it? All of you got it, right? No. What is the maximum torque? In which orientation does it experience maximum torque? In which orientation there will be maximum torque? The maximum torque will be, maximum torque happens whenever x-axis is parallel to plane of coil. Parallel to plane of the coil. That means what? If it is parallel, then it is normal to x-axis will be what? 90. So theta will be what? 90 degree. Parallel means it's better to write instead of parallel, x-axis is in the plane of the coil. That is the parallel. If parallel means theta is not 0, theta will be what? 90 degree, because we are taking what? Normal to area. I hope that is clear. Sweda, if that is clear, lying in parallel or lying in the plane means what? Theta will be what? Normal to area. So theta becomes what? 90 degree. Yeah. I hope you got that. Done, right? All of you done. Next question. A current of 5 ampere flows through each of the two parallel wires. The wires are 2.5 centimeter apart. Calculate the force acting per unit length on each of the wire. What will be the nature of the force if both current flows in same direction. Both current flows in same direction. Now, I1 is equal to I2 is equal to 5 ampere because 5 ampere current is flowing both of them. Separated by what? Distance 2.5 centimeter, that is 2.5 into 10 raised to minus 2 meter. And they are asking for force per unit length. So formula is mu 0 I1 I2 divided by 2 pi r. So mu 0 is 4 pi into 10 raised to minus 7 into 5 divided by 2 into pi into what is our 2.5 into 10 raised to minus 2. If you solve that, your answer will be 2 into 10 raised to minus 4 Newton per meter. Now, since I carry current in same direction, force will be what? Attractive. Force will be attractive. Any doubt? Any doubt? Simple question, alle. Very simple, right? Direct question. Done? Any doubt? All of you done, right? Simple question. Next question. An electron travels in a circular path of radius 20 centimeter in a magnetic field of 2 into 10 raised to minus 3 Tesla. calculate the speed of the electron. Calculate the speed of the electron. Calculate the speed of the electron. What is the potential difference? What is the potential difference through which electron must be accelerated to acquire this speed? To acquire this speed. Electron travels in a circular path of radius of what? R equal to 20 centimeter. So 20 into 10 raised to minus 2 meter. Okay. Magnetic field is what? 2 into 10 raised to minus 3 Tesla. Okay. Magnetic field is 2 into 10 raised to minus 3 Tesla. Okay. Speed of the electron that we have to find out. We know that V equal to BQR by M. So V is equal to, B is what? 2 into 10 raised to minus 3. Charge of electron 1.6 into 10 raised to minus 19. Radius 20 into 10 raised to minus 2. Divided by mass of electron 9.1 into 10 raised to minus 31 kilogram. Don't say that charge and mass of electron are not given. KBFC fan. I am also KBFC fan. Okay, if you solve that, you will get the answer 7 into 10 raised to 7 meter per second. That is the velocity. Now, what is the potential difference through which electron must be accelerated to acquire this speed? Now, that is a tricky part. See, now remember, I don't think remember is the right word, because first time you are understanding this equation. There is an equation for kinetic energy, that is charge into potential. And you are not aware of that equation, that you will study later. For kinetic energy, there is an equation, kinetic energy is equal to charge into potential. Please remember that equation. Kinetic energy, there is an equation, charge into potential. So kinetic energy is equal to, we know the another equation, half mv square. See, this equation will be very helpful for you. Kinetic energy is equal to charge into potential. How we are getting this equation, that you will study, I think, in the 12th chapter only. So as of now, just by heart that there is an equation for kinetic energy. What is that? The charge into the potential through which the charge is moved. So when a charged particle moves through a potential difference, it acquires a kinetic energy given by the equation K equal to EV, where K is kinetic energy, E is the charge of the charged particle that is moved, and V is the potential difference through which the charged particle is moved. So there is two equations for kinetic energy, EV and half mv square. By equating EV equal to what? Half mv square. Now remember, some students will cut this V. See, this V is potential and this V is velocity. This V is potential and this one is velocity. So you cannot cancel them. So V is equal to, and we want what? Potential. So V equal to what? mv square by 2e. What is mass? 9.1 into 10 raised to minus 31. And what is velocity we got? 7 into 10 raised to minus 7 into 10 raised to 7 the square, v square divided by 2 into charge of electron is what? 1.6 into 10 raised to minus 19. If you solve that, you will get the answer almost 14 kilovolt. This is class? Biology class. K equal to AV. K is what? K is what? Kinetic energy. And the equation for kinetic energy is what? Charge into potential. See, remember there is a equation for kind energy. All of you are familiar with the half mv square. There is one more equation, EV, charge into potential. V is what? Now, we have two equations for kind energy. One is EV and the other one is half mv square. We are equating. Remember, V is potential. There are students who keep on what we say, cut ചെയ്ത് കളയും. ഈ രണ്ട് ബിയും കട്ട് ചെയ്ത് കളയാൻ പാടില്ല, ബിക്കോസ് ഒരെണ്ണം പൊട്ടൻഷ്യലും മറ്റേത് വെലോസിറ്റിയുമാണ്. എന്നിട്ട് പൊട്ടൻഷ്യൽ വി ആർ റൈറ്റിംഗ് ഇൻ ദ ടേം ഓഫ് writing equation in the term of potential. Then we are finding out the values. We already know the velocity, mass we know, and charge we know. Any doubts? Note ചെയ്യട്ടാ. കിട്ടിയ മക്കളെ, കിട്ടിയ? ഇത് മനസ്സിലായി എങ്ങനെ ചെയ്യാന്ന്? ആകെ ഇവിടെ നമ്മൾ പുതിയൊരു ഇക്വേഷൻ പഠിക്കുന്നത് കൈൻഡ് എനർജി ഈസ് ഈക്വൽ ടു ചാർജ് ഇൻറ്റു പൊട്ടൻഷ്യൽ. അത് മറക്കല്ലേ, വളരെ ഹെൽപ്ഫുൾ ആയിരിക്കും ആ ഇക്വേഷൻ എൻട്രൻസിന്. അപ്പോൾ ഓക്കെ, താങ്ക് യു ടാ. ഗുഡ് നൈറ്റ്. വീക്കെൻഡ് ആണ്, എൻജോയ്. അപ്പോൾ ബൈ ടാ. ബൈ ബൈ, ഓൾ ഓഫ് യു ബൈ.